Humans have lived on the Earth for all of their existence as a species. But how have we learnt what the shape and size of our planet really is? Why and how did the generally accepted idea that it is roughly spherical come to be the generally accepted idea? The story of how we learnt about the Earth parallels how we learnt about ourselves and our place in the universe. That human journey can tell us a great deal about ourselves and our development over time. I'm Dr. Bill Hazelton. Please join me as we explore how humans discovered the planet Earth. There is an old joke about the shape of the Earth that goes something like this. When I was a small child, had I thought about the shape of the Earth at all, I probably would have said that it was roughly flat. After all, it looks flat from the perspective of a small child. When I went to school, they told me that the shape of the world was round. This was a bit problematic. Was it round like a plate? Like a cup? Like a bowl? Like a donut? Like a cake? Like a ball? Like a hamburger? When I went to high school, they told me that the shape of the world was a sphere. Okay, that's round and a lot more specific. We did get flat maps with a rectangular outline, but when I went to university, they told me that the shape of the world was an oblate ellipsoid of revolution, but almost the same as a sphere. This was clearly a refinement of the sphere idea. When I got to the upper level surveying classes, they told me that the shape of the world was a geoid. So I went and looked up geoid in the dictionary. I found that geoid meant earth-shaped. So there you have it. The shape of the Earth is earth-shaped, and that's official. Okay, that's a joke, but it does follow the way that humans have learnt about the shape of our world, if you leave out the elementary or primary school bit about it just being round. Keep that joke or story in mind as we go to the earliest days of the human species, many millennia ago. We need to explore several different concepts to get to geodesy, but stick with me. Geodesy and surveying have a gradual history and development, and they reflect some critical developments in our species and its culture. There are relatively few peoples alive today who are like early human groups. The few remaining hunter-gatherer societies are rapidly disappearing, and with them goes their culture and our connection back to those earlier times. If we take as an example the Australian Aboriginal people, we find that they never bothered with the shape of the Earth. They had elaborate stories from the dream time, the beginning of time, that explained how their immediate world came to be. Hills, rivers, plains, rocks, etc. Their connection from the dream time to the present came through dreaming, which seems to be a significant part of spiritual practices. They did not have a god or gods, but a great number of spirits that animated their world. Creative beings may have moved on or remained as spirits in specific landscape features, and multiple beings may have been responsible for creating the landscape out of a featureless domain. Creation may have been responsible for very large features that cross thousands of kilometers, and the creation stories match geographically verified events from 10,000 or more years ago. People tended to be created around the same time as the landscape. Each tribe had its own particular area, but this was not the limit of their knowledge, as there were movements into adjacent tribal areas for limited trade and certain ceremonies. What was important was that these people had no sense of ownership of land, as it's understood today. If anything, quite the opposite. The land owned them in a way. They were part of it, and forced separation was traumatic. Their law, spiritual practices, way of life and living were completely intertwined with the land. There was no separation. So they accepted the world around them just as it was. They lived within it and managed it in quite complex ways. But their view of the world was necessarily quite local. They had no need for a concept of the entire planet. It was simply beyond their sensory range. This is an important concept. Our senses have a very limited range. Touch and taste have to be immediate, while hearing is short range. Smell relies on the scent coming to us. Only vision allows us to perceive things that are far from us, but it is limited by our visual horizon. The sky stretches overhead from one visual horizon to the other, and even if we know that there is more beyond the horizon, it is still a compact world in which we live. So the sensory range limits our need to explain the world around us. Anything that doesn't fit in with what we know from within our sensory range is nonsense or nonsensical. It's outside our senses. Our common sense derives from what we learn within our sensory range. Therefore, things that are outside our sensory range may appear counterintuitive and to not make sense when we encounter them. One other important point to note is that these people considered themselves truly inseparable from their land and their environment. While they managed the land and its ecosystems, they did not consider themselves as being essentially separate from the land. They were part of the land, and the land was part of them in a very deep state of interconnection. If you look at what these people thought about the world, their understanding was a little like that of the small child in the joke. Had they been asked to describe the shape of the earth, they probably would have suggested a flat earth, as that was what was within their sensory range. But even then, the idea that there was a far larger world would not necessarily have made sense, as it wouldn't accord with their sensory perception and sensory range. It would just be a nonsense to them. Of course, this is not to suggest that the Aboriginal people or other hunter-gatherer groups were childlike or simple in any way. They had a complex culture that they had developed and transmitted for over 40,000 years without using writing, which was far longer than any other culture that we know of. And they had a very deep and subtle understanding of their world. They also developed a device that could be thrown further than anything else invented by cleverly exploiting aerodynamics, the boomerang. But the shape of the planet would be a meaningless concept to them, both because of their sensory range and because they did not see the world as something that was truly separate from themselves. This appears to have been similar for other peoples across the world in similar situations. So we find that a flat Earth model is, pretty much, the default human interpretation of the world. This is based on human sensory perception, which is limited by sensory range, together with a limited need to have a more advanced model. For tens of thousands of years, humans had no need for any model for the planet, or even knowledge that they were on a planet. They lived within the range they could sense and how far they could walk. They developed complex cultures and social systems and passed down knowledge and skills through their language and culture. In the same way, a child today can enjoy a happy and fulfilling childhood, unencumbered by concerns that are on a planetary scale. The development of agriculture produced some major changes in humans and their culture. Among hunter-gatherers, a person was part of the land and its ecosystems and went along with how the world was working. Not having possession of land, in any modern sense of ownership, warfare among hunter-gatherer societies was almost unknown. Weather, drought, famines, fires, earthquakes, these were simply things that happened and you had no control over them. With agriculture, people didn't have to move to get food. They produced it where they were. There were cycles of the seasons that needed to be known so that one could plant at the right time and harvest at the right time. Food tended to come in one big harvest, and it had to be stored to last the rest of the year. Seed needed to be stored for next year. Land needed to be tilled and prepared for sowing, seed needed to be sown, crops protected, and the harvest gathered. This is a very different environment for hunter-gatherer humans. The aptitudes and skills needed for hunting and gathering are different to those needed for farming. People are taking some control over the land and making it conform to their will. They are no longer completely under the control of the land. While people and their activities need to conform to the cycle of the seasons, people decide which crops are grown and where. This requires a different mindset compared to the hunter-gatherer. It also requires more specific knowledge of the seasons, and it starts the separation of humans from nature and the land. We are no longer part of the land, even if there are strong ties. We are starting to take some control over our immediate environment. Hunter-gatherers also controlled their environment. For example, Australian Aboriginals used fire as a land management tool to keep the feed fresher to attract animals that could be hunted. But agriculture is a different form of control. Fire manages ecosystems. Agriculture creates ecosystems. By creating a new ecosystem, however small, humans moved out of the world's natural ecosystems and into one of their own creation. With agriculture, people now lived in the one place rather than moving through a range. This encourages building permanent shelter as well as storage facilities. So being able to envisage something like a house or a barn and then build it becomes a new human skill. Finding materials like wood and stone is one new skill, as is being able to make bricks and thatching. Farmers need to protect their food stores from the elements, from nature, and from other people. Adopting agriculture also means that people do not need to move around, so they start to acquire things, to make things. So we find the development of elaborate crafts, especially ones that need more complex resources, like looms and forges. Humans now start to build out their creativity, imposing their will on an increasing number of different existing materials and creating new materials, such as glass and metals. From the earliest times, we see artistic adornments and decorative touches. Human creativity goes beyond mere utility and touches an aesthetic sense. We humans have an innate sense of beauty that is a very deep and very human characteristic. As people started to form into groups larger than clans of farmers, we start to see the development of more complex social forms, larger aggregations, and a greater degree of organisation required. We find that organised agriculture arises. One of the earliest forms of organisation occurred along the Nile River in Egypt. An important characteristic of the Nile was its annual flooding, which provided fresh silt and nutrients to the areas beside the river. This, in turn, allowed agriculture to flourish and to create economic surpluses. However, the annual flood obliterated the outlines of fields and parcels of land. In ancient times, a flood was a real symbol of chaos. Floods appear in ancient literature as a visitation of chaos rather than destruction. Volcanoes and earthquakes are symbols of pure destruction. So floods were chaotic in both reality and symbolically. But people discovered that they could recreate the previous arrangements of fields and land parcels after the flood by measuring the fields before the flood, storing the measurements, and then reapplying them to the land after the flood. This discovery was repeated or spread across the ancient world, appearing in Mesopotamia, Egypt, and other civilizations. What is important about this discovery is the ability to repair natural chaos. Not only can humans create their own small ecosystems, when nature sends them a disaster, they can master it. For something like the Nile's annual flood, it can also be predicted. With this skill, human civilization can further separate itself from the landscape and start to take control of the landscape. It's a small beginning, but it will take us a long way. The Egyptian and Mesopotamian civilizations needed measurement to support construction and land management. They developed a range of basic surveying skills, especially using distance measurement. The priestly class undertook extensive astronomical observations to support the development of a calendar, a necessary tool for agricultural planning. The Babylonian mathematicians developed the sexagesimal 60ths system we still use for minutes and seconds of both time and angle. They also created the 360-degree circle and the 24-hour day. The Egyptian surveyors discovered how to form a right angle reliably and to do basic levelling to get the bases of buildings and pyramids flat and level. Even among less advanced societies, observations for time and calendars were important. Among the early inhabitants of Western Europe 5,000 to 10,000 years ago, we find that Stonehenge is carefully aligned to the point where the sun rose on Midsummer's Day at the time of its construction. In western France, at Locq-Mariaquer, there are a set of large stone markers set across a large bay that align to show the most extreme north and south rising and setting points of the moon. As the moon takes about 19 years to go through a full cycle, these people clearly undertook the project for at least twice as long, so as to be sure they had a complete cycle. Various ancient civilizations developed ideas about a flat Earth, largely through mythology and speculation. The Earth was a flat disk floating in the ocean and surrounded by a spherical sky in early Mesopotamian mythology. Some ancient writings describe a 7-layered mountain or ziggurat. The Chinese developed a flat Earth model with a square shape, the Four Worlds. Jainism has a 3-layered world. Buddhism has infinitely many worlds, but many seem to be levels of consciousness. Like Hindu cosmology, which also has infinitely many worlds, it is also cyclic over time. Other societies developed other models, but not all of them have survived. By 5,000 years ago, the northern constellations had been designated, named, and mapped. The fact that a select few stars wandered, planets, while the remainder remained fixed had been noted, and the passage of the sun through the various constellations had been figured out. What we see here is further separation of humans from the land, the development of a range of tools to manage the land, efforts to master the land, and efforts to understand the sky. Humans during this time are moving further away from a direct connection to the land to a point where they are working to control the land. The ancient Greeks were keen to find out how things worked. They had several advantages to help with this. They were able to develop a prosperous society, which allowed a number of people some leisure time to consider these things. Often, these people were also teachers. The ancient Greeks also had a few other advantages, such as access to much of the learning of the Egyptians and a religion that had very little concern about the nature of knowledge. The ancient Greek philosophers, which means those who love knowledge, not only sought knowledge, but also sought tools to help them know that they were on the right track of knowledge. They were well aware that false knowledge was all too possible, and they wanted to guard against it without cutting off the possibility of learning something new. Among the thinking tools they developed were the hypothesis, which allows you to advance an idea for consideration without having to own it or make any claims about it. Logical thinking, which allowed thinking to proceed from what was known to be true by concrete, testable, and repeatable steps to demonstrate that something else was true. And abstraction. Abstraction allows you to separate the essential idea of something from its realization in the real world and consider its pure form. So we know that if we want to create a square piece of wood or metal, we cannot make it perfectly. But if we think about an abstract rectangle, we can have exactly right-angled corners and exactly matching side lengths. Today it is easy for us to think in abstractions, but the ancient Greeks are the ones who really brought this into the mainstream. In fact, they created what we now think of as mainstream thinking, logical argument working from known information. The logical thinking allowed them to consider ideas and test them against evidence and measurement, while the hypothesis allowed them to work with ideas as neither right nor wrong until they had been tested. The idea of abstraction allowed them to develop mathematics from something that was totally practical into something that was abstract but far more powerful. They considered that geometry was the basis of all mathematics, and so focused on work that developed geometry to new heights. From this new mental state, they considered the world. They looked around them and wondered about this world in which they lived. Perhaps for the first time, a culture was sufficiently disconnected from the world to consider how it might look from well outside it. Since they couldn't do that, they sought evidence of how it might be in terms of shape and size. While surveying had been in existence for thousands of years and the Greeks advanced its practice, this was the real beginning of geodesy. So what evidence did they have? What ideas did they start with about what it might be like? What hypothesis did they advance for a possible shape? Because the Greeks considered geometry to be the highest science, they also had some ideas about abstract shapes. They considered the circle to be the perfect shape and the sphere to be the perfect solid. By analogy, if the Earth were perfect, it should be a sphere. So a sphere was one hypothesis, and it seemed to have been advanced by Pythagoras in the 6th century BC, or perhaps by Parmenides in the 5th century BC. Another hypothesis was that it was flat. Now they had to undertake some kinds of practical tests to see if they could tell which shape it really was. One test was based on watching the moon. They had figured out that the moon shone with reflected sunlight, so the way that the sunlight fell on the moon could tell them about its shape. Although we only see the one face of the moon as the sun's light falls on it, it doesn't act like a flat plate. It acts like a sphere, showing phases with curved edges. This strongly suggested to them that the moon was a sphere, which also suggested that the Earth may also be a sphere. The ancient Greeks also figured out the nature of eclipses. They knew that a lunar eclipse occurred when the moon, Earth and Sun were exactly aligned, so that the moon passed through the Earth's shadow. When they watched the moon pass through the Earth's shadow, the edge of that shadow was always a circular curve, as best they could tell, regardless of the time of night that the eclipse occurred. As the angle to the sun kept changing throughout the day, but the shadow was always circular, the only shape that always casts a circular shadow from any angle was a sphere. As there are about 2 lunar eclipses each year, they had plenty of opportunities to observe these lunar eclipses. While not conclusive, this strongly suggested that the Earth was spherical and argued against the idea of a flat Earth. Because they could also see the whole of the shadow on the moon, it gave them an idea about the shape of the whole Earth rather than just something local. As the city-state of Athens was a serious seafaring power in ancient Greece, the ancient Greeks were very well aware of ships sailing to and from many places throughout the Mediterranean Sea. They knew that as a ship sailed away from the shore, it eventually started to sink below the horizon, and they could even measure this in terms of approximate distances and the amount the ship went down. They found that the rate at which ships sank below the horizon was consistent in all directions and from all points they had visited, and the same occurred with ships in the middle of the sea. Again, the only shape with consistent curvature in all directions is a sphere. They also knew that when travelling overland, mountains gradually rose up before them when they travelled towards them, and sank down as they travelled away, so the same effect also occurred on land. While they knew that these observations were very much local on a very large planet, they were consistent with the idea of a sphere, but not what you would see on a flat Earth. As the Greek seafarers travelled between Crimea in the north of the Black Sea and the Nile Delta, they also saw that the stars moved north and south as they changed their latitude. They knew that the heavens appeared to rotate around the pole star, Polaris, in a very consistent way, and they observed that the location of Polaris and the whole of the heavens shifted their angle above the horizon smoothly and evenly as they travelled north and south. Whether you assume that the stars were a very long distance away or on the inside of a hollow sphere, their smooth and even change with movement suggested that the area of the Earth over which they were travelling was roughly spherical. Aristotle, who lived between 384 and 322 BC, also argued that as there was a downward tendency everywhere on the Earth, it would tend to bring everything towards a central point, until by compression and convergence it formed a sphere. Although Aristotle wasn't aware of gravity as a distinct force, the tendency of things to move downward strongly suggested to him a spherical planet. Aristotle even suggested that there were 5 climatic zones on the Earth, 2 temperate zones separated by the torrid zone at the equator, and 2 frigid zones at either pole, impenetrable and girdled with ice. All of these arguments were well known, and after the 5th century BC, no Greek writer of repute thought that the world was anything but spherical. This knowledge was disseminated throughout the known world, albeit slowly. In India, the spherical nature of the Earth was widely accepted from transmission of Greek writings. Roman writers also assumed the Earth was spherical. We can see here the beginnings of the scientific method. Hypotheses are advanced, evidence is collected and interpreted to see which hypothesis is supported, and conclusions are drawn. All the evidence available to the ancient Greeks supported a spherical model of the Earth, and none of it supported a flat Earth model. So the ancient Greeks did the logical thing and adopted the sphere as the shape of the planet. Of course, they recognized that it was lumpy in some places with mountains and wet in others with sea, but they also had the idea that they could consider the planet as a whole as an abstraction and represent it with a general spherical shape. 2,500 years ago, people who knew that they knew no more than a quarter of the planet were confident of its shape, that it was approximately spherical. From that time on, the consensus was a spherical shape. Human beings, rarely ever more than 2 meters tall, had determined the shape of the planet they lived on, a sphere some 12,600 kilometers in diameter, which is over 6 million times larger than the tallest humans. Perhaps most importantly, humans were now thinking of themselves as somehow completely separate from the planet while still living on it. Only a couple of thousand years before, they were completely part of the world. Now they were separate beings. They were on their way to finding out about the universe. With the shape of the Earth now settled, the next big question was, how big is it? This was a difficult question to answer, especially if you realize that everyone you've ever heard of has only travelled to a small portion of it. The person of importance here is a Greek polymath named Eratosthenes. Eratosthenes was born in 276 BC in the Greek city of Cyrene, in what is now eastern Libya. As a young man, he travelled to Athens and studied under many Greek masters. He was not only a published author in mathematics, but he also wrote poetry, history, and created the discipline of geography. He also developed a calendar of 365 days, with 366 days every fourth year, the first such calendar. Eratosthenes was hired to work at the library in Alexandria in Egypt, and within 5 years was chief librarian. He expanded the library's collection, including compulsory collection and copying of all books that came through Alexandria. So he had access to most of the knowledge of the ancient world, including the complete body of Euclid's Elements, the foundation of geometry. As chief librarian, Eratosthenes had read reports that at the summer solstice, Midsummer Day, around the 21st of June, the sun shone straight down a deep well at noon in Syene, now Aswan, in southern Egypt. In Alexandria, he measured the angle of the sun from the vertical at noon at the summer solstice, knowing that the repetition in the sun's behavior every year was consistent going back hundreds of years. He found that the angle was 1/50th of a circle. The direction and distance from Alexandria to Syene was known from extensive records of surveys in Egypt, with the distance updated annually, and Eratosthenes knew that Alexandria was pretty much due north of Syene. Given the distance of about 5,000 stadia, and the angular difference in the direction of the sun's rays at the summer solstice, and assuming that the Earth was spherical, Eratosthenes concluded that the circumference of the Earth was about 50 times 5,000 stadia, or 250,000 stadia. But how long was a stade? The exact value is not known. It may have been the Olympic stade of 176.4 metres, or perhaps closer to the later Italian stade of 184.8 metres. Depending upon the length of the stade in question, Eratosthenes was within about 10 to 15% of the value we accept today, and given his simple equipment and his assumptions, this is a surprisingly good result. This value would not be improved upon for almost 2,000 years. It is also claimed that Eratosthenes calculated the distance to the sun, although the original information has been lost. Depending upon how the reports are translated, the value given is very close to current estimates. Other geometers of the day calculated distances to the sun and moon, as well as their diameters, obtaining a wide range of results. By 200 BC, learned people in the Western world had information that the Earth was a spherical planet. They knew its approximate size and very approximate distances to the sun and moon. In other words, they had a good grasp of the shape and scale of their universe as far as they could easily see. This is a huge advance from just a few hundred years before. Over a period of perhaps 300 years, humans had moved from a flat Earth model to a spherical model, with proofs for why this model was accepted, and even the approximate size of the planet was known. The scale of the local part of the universe was also being estimated. So people were now starting to measure into space, moving away from the Earth, at least in their minds. The mental separation of humans from the land and from the planet was now moving in earnest. The spherical Earth model was accepted by all informed people and has been the accepted model for about 2,200 years of human history. Ancient Greek learning spread throughout the world. The spherical model of the planet was adopted by Indian mathematicians when the information reached there, around 200 AD. It was accepted around 1700 AD in China, when Jesuit missionaries brought it to the emperor's court, although in a great example of historical revisionism, Chinese scholars of the day went back and tweaked ancient Chinese texts to suggest that it had been suggested in China first. The Christian Church adopted the spherical Earth model and has never abandoned it. Even during persecutions over heliocentric models of the solar system, there was no question that the planet itself was spherical. During the scientific flourishing under early Islam, the spherical Earth model was adopted, and Muslim mathematicians developed spherical trigonometry to solve problems like which way to face in order to be facing Mecca when praying from anywhere in the world. Improvements in measurement technology have allowed us to refine the spherical model in more recent centuries, but the spherical model remains a perfectly good approximation for a large number of everyday needs. We have seen the historical development in our understanding of the size and shape of our planet. In the next few sessions, we will look at how we have been able to refine the spherical model and some of the interesting things that have sprung up along the way.